Hello guys and welcome back to my channel Interview with Bunny. And here finally after waiting for months, finally I'm releasing the backend architecture for our Amazon cloning app. So sorry for the delay. I know many of you guys were waiting for this video for so long, but sorry for this delay. So let's start with this video. And today in this video we will be discussing about the backend architecture for our Amazon cloning app. So in our last video tutorial, you have seen that how with the help of the React, we have developed the front end of our Amazon cloning app. And here in this video, we will be dealing with the complete backend and we will try to understand in depth that how we can build the complete backend architecture of the Amazon cloning app using the Java Spring Boot framework. So I can bet you there will be a plenty of things that you will be learning about the backend architecture and different topic of microservices while we will be designing and developing the backend for our Amazon cloning app. But before we start with the implementation with the code, let's first understand that what are the things that we will be learning over here, what are the main things that we will be developing while implementing the backend service. So here basically we will be focusing mainly on three components. One is the user microservice, one is the product microservice, and one is the add to cart microservice. And within all these three types of microservices, we will learn different type of functionality of the microservice. So let me first explain you what you will be learning over here. So while developing the user microservice, there we will learn how to create a simple microservice, and with the help of that simple microservice, how we can create our REST API for our front-end UI. And here we will be connecting with the MySQL database, which is a relational database. Now, in the next microservice, that is the product microservice, here you will know how to connect with a NoSQL database, and that is with a MongoDB. So in our previous video, while I was doing the cloning of the Facebook and Instagram, there I have used the Cassandra database, which is also a NoSQL database. But here for this microservice, I will be using the MongoDB. And I believe with the help of this microservice, you will get to know how to connect a NoSQL database with a Spring Boot application. And the next microservice that we will be dealing with is the add to cart microservice. And here also we will be using the simple MySQL database. But the main thing that we will be learning over here is we will be mainly focusing on how to do a intercommunication between the two microservices. Means with the help of this third microservice, we will communicate between the other two microservices, that is the user metadata service and the product metadata service. So here we will see in detail that how with the help of the Spring Boot application and Spring Cloud, we can easily communicate between the two microservices running on different server and in different port. But as of now, I can simply tell that there are a lot of content that you will find in this video, and at the end of this video, you can easily tell that you know how to create a REST API using the Spring Boot application. So let's first focus on some of the basic attributes that you need to know before we start with the implementation of the microservice. So here in the user microservice, here what we will be doing, we will be storing all the information of a user. For example, the name, address, customer ID, email ID, phone number, and many more attributes of the user. Similarly, in the product microservice, here we will be saving the product name, description, price, rating, and plenty more details of a single product in the MongoDB, so that it will be very easy for us to retrieve the data while we will be scaling up our application. And in the last and the add to cart, here we will be storing a simple mapping between the user ID and the product ID, by which we can get to know that which user is actually putting which product in their cart. So I hope you got the basic idea that what are the three microservices that we are planning to implement and what are the different use case of this microservice. Let's now move to our next slide. So here you can see, as I've told you already, that in our last microservice, there we will learn something new, and that is how we can communicate between the two microservices that we will be creating at the very beginning of our video. So stay till the end of this video so that you can understand the complete flow, that how progressively we will be creating each and every microservice into our application and how we will make it communicate with each other. Now let's come to the most important thing, and that is what are the endpoints that we will be creating for our REST API. So primarily for the metadata service, we will be creating two REST API. One is the post service for saving the data into the database, and another is the get service for retrieving the data from the database. And as an enhancement to our problem, you can also create the put and delete for updating and deleting a user from the database. But this enhancement problem, I will leave it for you guys so that you can also implement along with me and you can learn something new. Similarly, in our next API, that is in the product metadata service, there we will be creating three API endpoints. One is the post service for saving the product details in the database, the get API to get the list of all the products that are saved in our database so that we can display the products in our front end, and number three, another get service for getting the list of all the details for a particular product based on that ID. So here we will see that based on the product ID, how easily we can retrieve the data from a MongoDB NoSQL database. And here also for the enhancement problem, you can implement the put and delete for updating the product details and deleting our product details from our database. And the last and the final service that we will be creating is the add to cart service. And here also we will be focusing on three REST API endpoints. One is the post for putting an item into the cart, delete for removing an item from the cart, and get for retrieving a particular cart for a particular user. For example, for your user ID, this API will list out all the products that you have added into the cart. And while developing this endpoint, here only we will learn how we can do the intercommunication between the microservices. So along with this, I will be sharing plenty more tips and tricks of how to develop a backend microservice architecture so that you can easily learn the total microservice architecture and you can create any REST API endpoint as you require. So to summarize everything, while we will be implementing the backend for our Amazon cloning app, here we will be learning primarily 5 things. One is how to build an end-to-end microservice using a Spring Boot application. Number two, how to create a REST API for a distributed system. Number three, how we can do a intercommunication between the microservices sitting on different environment. Number four, how we can integrate a relational and a non-relational, that is a NoSQL database within the Spring Boot application. And number five, a plenty of tricks and tips of how to create a Spring Boot microservice architecture. So I'm pretty hopeful that you will definitely love this video and you will definitely learn something at the end of this video. So do watch this complete video and please let me know your feedback in the comment section, and also feel free to ask any question in the comment section. I will be happy to help you over there. But before starting this video, I would like to request you, please do like and share this video. So without wasting much time, let's start with this video. So let's start with creating the first microservices, and that is the user metadata services. And for that, to create the Spring Boot microservices, we will go to the Spring Initializer app. So let's go to the Google and type Spring Initializer. And within this Spring Initializer application, we'll first rename the artifacts and the name of the project. So let's name it as user metadata. And that's it. We will keep the setting as it is. So here you can see our project will be a Maven project and the language will be Java. And here you can select any of the version of the Java, whether it's 11, 8 or 70. So let's keep it default with 11. Now let's add the dependency for this Maven project. So the first dependency that I will be adding is the Spring Boot dev tool that will help us to create the project very fast. So let's select this. The next dependency that we need is the REST service. So here we will be selecting the REST repository. And that's it. Now we will select one of the database for creating this user metadata service. And as I have already told you, for creating this user metadata service, we will be using the plain old relational database, and that is the MySQL database. So here we will be selecting the MySQL driver. So as of now, these three are the main dependencies that we need for creating the project. So let's now click on generate and let's download the starter project for our application. So here you can see the project got successfully downloaded. Let's now unzip it and let's import it within our IDE. So over here I will be using Eclipse IDE. If you are not familiar with Eclipse, feel free to use any IDE that you are familiar with. So let's proceed with importing the project. Now let's import the project that we have downloaded from the Spring Initializer application. So let's click on import project, and over here we will be selecting the Maven application. So here we will be selecting the existing Maven application. Let's click on next. Now let's select the directory that we have downloaded. So that is in our download folder. So let's go to the download, and here is our project, and that is the user metadata. So let's select this one and click on open. And that's it. Here let's click on finish. So now you can see all the Maven dependency are getting installed over here. So it will take a couple of minutes to download the entire application. So let's wait for some time. But meanwhile I will change the setting for the Eclipse because I do not like this dark theme, rather I will go to the default one. So let me change the appearance for this Eclipse as of now. So here you can see I'm done with the basic setup of the Eclipse. So I'm ready with the project with all the dependencies already installed, and also have changed the required default setting of the Eclipse. So without wasting much time, let's start with the implementation of this user metadata service using the Java code. So since this application will be a Spring Boot microservices, so over here we will be creating 4 folders. Number 1 is the entity class, which will comprises of all the entities within our application. Number 2 is the controller, which will control the request for each and every URL for our REST service. Number 3, the service folder, which will comprises of all the business logic for our user metadata. And last but not the least is the repository, which will actually connect to our database service. So let's first create 4 directories over here. So here we are done with creating all the 4 packages for our application. Let's now start with our first package, and that is the entity class. And as I've already told you, for this microservices, the entity package will have only a single class, and that is the user metadata. So let's create the first class called as the user metadata, and over there we will be storing few of the attributes of the user which we have already discussed few minutes ago. So let's first create a class called as user metadata. And since this class is actually a representation of the table, so here we will be annotating this entity class with @entity, which will be from the JavaX persistent. And here we will be giving the name that we want to suggest for this table. So let's give the name as the user. So let's first see what are the attributes that we need to add for this user table. So as I have discussed, the first attribute that you need to have is a ID. So over here I will be first defining an ID, which will be basically the primary key for our table. So over here I will be making it as ID, and I will be keeping it as an auto-generated ID. So let's give as generated value. So here the ID for this table will get generated automatically. Now the next attribute that we need to have is the username for a particular user. So you have to first understand that whenever a user is coming to an Amazon application, what he will be doing, he will be first signing up into your application with some of the login mechanism that we will be providing. So in our UI application, we can give different type of provision for the sign up mechanism. So for example, we can give login through Facebook, login through Google, or login using the sign up mechanism, which means that you have to fill a form to log into your application. So there are plenty of ways by which we can create an authentication system into our application. So in my previous video, that means when I was doing a Facebook clone and an Instagram clone, there I have shown you in detail that how you can create your own login system with the help of the Firebase application. So here also I will be doing the same thing. And if you had watched my previous video, you must be knowing that whenever we perform an authentication using the Firebase application, in the response of the Firebase, we get few of the attributes. Number 1 is the user ID, which will be a unique identifier for a user. Number 2 is the username. Number 3 is the email ID. And number 4, the name of the user. So there are a couple more metadata that also come in the response from our Firebase application. But most commonly, we just need the name, email ID and the unique identifier for the particular user. And that is only the reason why we will be saving only those parameters into our database. So let's first capture these 3 attributes, that is the name, email ID and the unique identifier into our application. So let's create 3 variables over here. So we are done with the basic attribute that we need for our user class. Now let's create the general setter and getter as well as the constructor for this class. And for that, you know, it's quite easy. We will just do a right click over here, and here under source we will be setting the constructor using field. So we will select all from this list and we will create on generate. And over here we will also create a default constructor for this class. And let's click on generate. So we are done with creating a default constructor and as well as a parameterized constructor. So we are done with minimum setup. Now let's create the getter and setter for these attributes. So we'll again go to source and here we will select the getter and setters for our class. So let's click on generate. And that's it. We are done with almost everything that we need for our entity class for the user metadata service. Now let's move to our main class, and that is the controller class of our application, which will actually help us to control different endpoints for our REST API. So let's go to our controller package and let's create the class called as the user controller. So we will name it as user controller. So let's click on finish. And the first thing that we have to do within this class component is we have to annotate it with the REST controller annotation. So let's give it as REST controller. And here also we have to specify the request parameter for this controller class. So if you see the endpoints that we have defined over here for the controller class, we will be using the request path like /amazon/user. And to establish that, what we have to do, we have to write request mapping. And within this request mapping, we have to give the URL that we are trying to point out. And that will be /amazon/users. Which means that with the help of this URL, the controller will redirect the traffic into this class that we are defining over here. Now within this user controller class, we specifically have to mention two endpoints. Number one is the post endpoint and number two the get endpoint. Which means that with the help of the post API, whenever a new user log into our application, we can take the data from the front end, and with the help of the post mechanism, we can save those data into our backend server. And the another endpoint that is required, that is the get mapping. And with the help of that get API, we can fetch all the details of the user from the backend to the front end. So let's first implement this two endpoint over here. After that, I will let you know in detail that what is actually happening in this application. So let's first create the two endpoints over here. The first one is the post service and the next one is the get service. So we will annotate it with the post mapping. And as per our documentation, here it will be save user details, which means that whenever someone will hit this endpoint with /amazon/users/save user metadata, the data that we will be sending as the payload to this service will get saved into our database. So let's create the function that will be responsible for handling this request. So here you can see this is the function which will handle all the functionality, that will handle all the requests that are coming using this request URL. And within this functionality, you can see we are setting a user metadata as a request body, which means that whatever the payload, which is called the request body, that we are sending from the front end will get captured within this user data variable, and this will be saved into our database. So without wasting much time, let's see how this entire data flow is happening within our application. But before that, let's also define the get URL mapping for this class. So similarly over here, you can see this is the function which will be handling all the functionality regarding the URL, that is /amazon/user/get-user-details/the user ID, which means that whatever the user ID that we will be passing over here as a path variable, for that user ID, we will be retrieving all the data from the user and we will be sending it in the front end in the form of the JSON. So if you are new to this thing and if you are finding it difficult to understand, just hold for a minute. Once we are done with the entire service over here, I will be explaining you in detail all the steps that I am doing right now, and after that it will be damn easy for you to understand this complete flow, and I can bet you after going through this entire tutorial, you can create any REST API that you need for the enhancement purpose or for your personal project. So let's move forward to the next part of our microservice, and that is creation of the service class. And for that, what I will be doing within this service package, I will be creating a user service class, which will handle all the business logic for driving this user metadata class. So let's name it as user service. And let me first annotate it with the annotation called as service. So as we know, this service class will be responsible for handling all the business logic for our class. So the first business logic that we have to implement is for saving the data into the database, and the next one is to retrieve all the data for a particular user ID from the database. So for handling this two functionality, we have to create two methods over here. So the first one will submit the data into the database, and the second service will retrieve the data from the database. So let's define two methods over here. So here you can see I have created two methods for handling the business logic for two functionalities over here. Now let's understand what we will be doing. We will be calling the user service class from the controller class. Let's see how to do it. So what we have to do, within this controller class, we won't be writing any business logic. Rather, what we will be doing, we will be delegating those work to the method that we have defined within the service class. And for that, what we have to do, we have to call the functions that we have defined within this service class, which means that from the user save details, from here we will be calling the service class method, and that is save user metadata to DB, which will actually handle all the business logic for our application. So let's see how we can call the user service method from this controller class. And to do that, we have to first create an object of this user service class. So let's define a reference over here. So here you can see I am creating a reference for the user service class, and here I will be annotating it with the AutoWare annotation, which will internally create an object of this user class. And what we will be doing, we'll write user service class dot save user metadata to DB, and over here we will be passing this variable as our request parameter, and that's it. So here you can see, with the help of this simple line of code, we are actually calling the functionality that we have defined within this service class. Now if you look carefully, this service class is actually returning a value which is of type user metadata. So also we have to capture it over here. So let's capture the return type over here, and here as the return type, we will be also sending this user as our return type for this endpoint. And let's save it, and that's it. We are almost done with creating the first functionality for our REST endpoint, and that is the save user detail. And the only pending activity for this service is we have to connect it to the database. So that we will do within a short period of time. Let's also do the same thing for the get user detail service. So what we will do over here, we will be calling the method that we have defined within the service class, because as I have told you, controller class is not responsible for handling any business logic. And here also you can see this is returning a user metadata object as a return type. So we'll also capture this over here, and let's return it from here. And that's it. We are completely done with the controller class for our application. Let's now start with the implementation of the service class of the application, and let's write the business logic of connecting it to the database application. And for that, what we have to do, before connecting it to the database, we have to create a repository class for our application. So what we will do within this repository class of this package, which we will name it as user repo. And here in their backend as a DB, since here we are using a MySQL DB, that's why we will be extending the CRUD repository over here. So let's extend the CRUD repository over here. And you can see within this CRUD repository function, we have to actually pass two values. One is the entity class and another is the unique identifier for this entity. So if you know, we are creating this repository class for the user metadata DB. So here the name of the entity class is nothing but the user metadata. So what we'll do, we will define the user metadata within this variable t, and since the unique identifier for this user metadata service is of type long, so over here within this id we have to define the data type of this unique identifier, which will be nothing but long. And that's it. We are done with creating the user repo for our service. Now let's see with the help of this repo class how we can create the user data service over here. So here you can see we have created all the files that are needed for our API service. Number 1 is the controller service, number 2 is the service class, and number 3 the repo class. So the service class will be responsible for controlling the business logic of the API, the repo class will be responsible for connecting to the database, and the controller class will handle all the requests from our front end. So let's now actually connect this repo class with our backend MySQL database. But before that, we will be initializing two methods within this interface class, which is the user repo, so that we can actually connect to the database. So the first method that we need to declare is the save method, by which we will be saving the metadata of the user into our database. So what we will do, we will call a function that is save, and within this save method, what we will be passing, the metadata that we will be getting from our front end, which is our user metadata. So let's define that into the parameter. And once this data gets saved into the database, we need a confirmation from this user repo service. And the confirmation that it will be returning is the same data that we are saving into the database, which means the user metadata. So I hope this is clear to you. So what we are doing, we are invoking a service that is called as save, and once the user metadata gets saved into our database, this save service will return a confirmation in the form of the user metadata object. And the next function that we will be defining over here is the get service for a particular user, which means that whenever our user log into our application, that is our Amazon application, we should be able to retrieve the corresponding data from our database. And for that, we will be declaring a function that is find all by unique ID. And here we will be passing the unique ID as a form of a string. So here also the return type will be the user metadata service. So let's understand that what we have done over here. So what we are doing is like whenever a user trying to access our Amazon application, we will be sending the user ID of the particular user, that is this unique ID, from our front end into our backend. And once we hit our backend service using this URL, that is get user details / the user ID of the user, for which we want to retrieve the preference service or all the metadata that are saving the DB, what internally will happen is this controller service will call this get user metadata from DB service that we have defined within this service class. So here the control will go to this service, and the service class will call the repo class method that we have defined within this interface, where we will be sending the unique ID as a parameter, and based on this parameter value that we are sending, we will get all the metadata of the user that we have sent within our database. So once we will be done with this complete flow, then it will be very easy for you to understand that how each and everything is happening over here. But if you look carefully, you will notice that within this user metadata service, we are actually not saving any important metadata over here. We are just saving the user name, unique ID and email ID over here. But in the real-time scenario, when we will be done with the entire application backend, over there we have to save a lot of more data for a particular user. So for example, we have to save some of the metadata of the user, like the wish list, the cart, and all these things within this metadata service. So for example, whenever a user log into our application, put an item into their wish list, the item product key will get added within the wish list added that we will be defining over here. So there are a lot of enhancement that we will be doing in the future for this user metadata service. But as of now, we will keep it simple and lightweight, and so we will be just saving the name, unique ID and email ID as of now. And once everything will be running flawlessly, after that we will start with the enhancement purpose. So let's start with connecting this service with our actual database. But before that, what we have to do, from our user service class, that is this one, we have to actually call the method that we have defined within this repo class. And for that, what we will be doing, we will be auto-varying the repo class over here. And based on this object that we have created, we will be calling the method we have defined within the repo class. So it will be save user metadata. So here we will be passing the metadata that we are getting from the front end into our database service. And similarly over here, we will be also calling the find all method that we have defined within our repo service. and here we will be passing the user ID that we are getting from the front end. And thus this complete the entire flow from our controller service into our repo class. So now the only pending thing that is remaining into this service is connecting to the actual database. And connecting to a MySQL database is quite simple. What we have to do, within this resource class we have this application.properties file, and within this application.properties file we have to enter some of the configuration and the setting to connect to our database. So let me paste it over here. So this is the configuration that we need for connecting to our MySQL database. So I will be giving this entire connection string in the description box. Do not worry about that. So the only thing that you have to change is you have to change the name of the database that you are using into a local, as well as the user ID and the password that you have set for the local. So normally by default, root is the user ID and password is the default password set by the MySQL server. So let's first go to the MySQL server and let's create a database called as user metadata DB. So for that I will be opening a terminal, and here I will be giving MySQL -u root -p. So this will ask for the password. Let me give the default password as password. And here you can see I have logged within the MySQL database. So here is the MySQL database. So let's create a database over here. So what we'll do, create database followed by the name of the database, which is user metadata database. Let's click on enter, and you can see one row got affected, which means that one database got created. So let's check the database that we have created. So for that we will be writing show databases. So let's check the database that we have created. So for that we will be writing show databases. So here you can see we got our database created, that is user metadata DB, which we have created just right now. So thus we are done with the setup that we need for our metadata class. So now you must be thinking that why I have used a MySQL database over here to create this service. So to be very frank, choosing a database is not an easy job, because there are a lot of aspects that you have to consider before choosing a database. What we believe is just because we have a trillions of or millions of data, we should go with a NoSQL database. But the fact is, this is not true. Based on the scenario and the use case of the user or the application, we have to choose the right database at right place. So for example, over here in this case, the metadata service will have a relationship between each other. And that is why, since there is a relationship between two or more databases, or there will be a connection between those two, and that is why we are using an RDBMS over here. But in future, when we will be creating some different service, for example the product service or any other service, since that will be dealing with a lot of data and there will be not a interrelation between the data, over there we will be using a MongoDB or a Cassandra DB for that use case. So selecting a DB is a challenging job, and based on the exact scenario, you have to choose the DB appropriately. So as of now, we will be going with this MySQL database for this service, and in the future services that we will be defining, there I will be using the Mongo or the Cassandra DB, so that it will be easy for you to understand how to write code for each and every database. So in the future, if you want to move to a separate database or for your application, you can do so with the help of this code. So let's now test this application and let's see whether the end-to-end service of this user metadata class is working or not. And to test this service, what we will be doing, we will be using a Postman client over here. So let's run this application and let's test the service using the Postman application. So let's first run this application. So you can see our application is running, and yes, it is up and running on port 8080. So let's now test this application using the Postman service. So we will open Postman over here. Great. So the first URL that we will be checking is the post URL, that is this one. So let's first test it with the URL mapping that we have given in our controller service. So what we will do, we will select as new HTTP request, and over here we will be giving localhost port 8080, since we are using the 8080 port. After that, followed by this URL, that is the controller URL, followed by the service URL that we want to trigger, which is save user data. So this will be our URL that we will be triggering, and the method by which we will be invoking this function is post. So we will be selecting as post. And if you know, for creating a post request, we need to send a body in our payload. So what we have to do, we have to select raw over here and select as JSON. So the body or the payload that we will be sending as a payload for this request is of type user metadata, which will have a name, unique ID and an email ID. So let's create a payload over here. And then comes a email ID. So our payload is ready, which we need to save into our database. And if everything is working fine right now, once we click on save, we should get this as a response from this request. So let's click on send. And great, you can see we are getting a response from our service, which means that our application is working fine and we are able to save the data into our database. So let's check out this data into our MySQL database. So what we will do, so over here using the terminal, we will log into our MySQL server and we will check the data that we have just saved right now. So the database that we are targeting is this one. So we are in the database right now. Now we have to go within the table which is actually saving the data, which is nothing but the user table over here, which we have mentioned as the name of the entity. So let's now see whether the data is getting saved or not. And great, you can see the data is getting persisted into our DB successfully, which means that our post API is working great. Let's now check for one more time. So for example, I will be changing the name over here a bit and also put a different unique ID and also put a different email ID. Let's click on send. And great, you can see another ID, which is an auto-generated ID, got created over here and the data got persisted into our DB. Let's also check the data in the database. And great, here you can see both the data are getting persisted into our DB, which means that our first microservice, that is the user metadata, is working perfectly. Now let's check the next endpoint that we have created, and that is the get endpoint. And for that, what we will do, we will first change the method as get, and after that we will change the request URL for this get mapping. So that will be get user detail followed by the user ID for which we want to get the data. So over here, if you see, we have two unique ID into our database. One is this one and another is this one. So let's try to retrieve the data for this first one. So I will copy this unique ID from here and we'll paste it into our request path. So this is the unique ID for which we want to get the data. So I'll get rid of this data from our payload and let's click on send. And if everything is working fine, we should get the user detail of this customer which is having the unique ID as this one. So let's click on send. And great, you can see the data got changed and we are right now getting the user detail of the customer having the unique ID as this one. So great, both the services are right now working fine. So we are done with the first use case, and that is saving the user metadata. Now as I have told you, we need to add few more attributes over here to make it complete so that actually we can incorporate this thing with our front end. And for that we also need to add few of the attribute, that is wish list as well as cart. But as of now I will leave it at this point and I will move to our next user service, and that is the product service, which will give the detail of the product. So let's move to our next microservice, and that is the product service, where we will be using the MongoDB as our database. So let's start with creating our another microservice, and that is the product service. So let's close this one completely and let's create another project from the Spring Initializer. So in our previous video tutorial where we were cloning the Facebook application, over there I have used the Cassandra database, and here in this video while we were implementing the user data service, there I have used the MySQL database. So right now if I can show you that how to incorporate a MongoDB into our SpringBoot application, then it will be easy for you to implement any type of database for your use case. So let's start with implementing the product detail application using the MongoDB service. So before that, what you have to do, you have to install the MongoDB into your computer. And to install a MongoDB application is quite simple. So if you just go to Google and try to find out that how to install a MongoDB into your computer, it will give you 4 to 5 lines of code to install that service. So that will be a very easy installation process, and that is why I will be skipping it as of now. One more thing, to use the MongoDB into our computer, I have used another service, and that is the MongoDB Compass. which will help us to visualize the MongoDB database much easily. So without wasting much time, let's start with creating our application using the MongoDB service. So the first of all, what we have to do, we have to first create a Spring Boot application using the Spring Initializer tool. I will be selecting a Maven project over here. I will select language as Java, snapshot as 6.4.2, and here in the Artifactory, I will be naming this as product detail service. And let's now select the dependencies. So let's select all the three dependencies as of now and let's click on generate. So here it will generate a project for me. So here you can see a project got downloaded, that is product detail service. So let's now import it within our Eclipse project. So the first thing that we will be doing, as you know, we have to first create three primary packages. One is the entity class, one is the controller, and one is the service class. So let's first create the first package, and that is the entity package over here. So let's name it as entity. Then we will be creating the second one, that is the controller, followed by the service class and the repo class. So we are done with creating all the packages. So now the implementation of this service will be quite straightforward and very easy to understand. So the first thing first is we have to first create the entity class for our application, and the entity that we will be saving or the entity we are targeting is the product entity, since this is a product detail service. So we will be creating a class called as product. Now if you have remembered one thing, when we are creating the front end of our application, there we need few of the attributes for our product. So let's see what are the attributes that we need into our product service for creating our front end UI. So here you can see, for creating the front end of our UI, we need a description of the product, and the description of the product will contain an ID, which will be a unique identifier, the name of the product, the rating, price, and the image of the product. So these are basically the very nominal definitions that we need for our product service. So let's also define all this attribute into our entity class. So the first thing first, we will be first creating an ID for a particular product. So this will be an ID, and the data type of this one will be of type big integer. Now you must be thinking why I'm using a big integer instead of a long or a int. So basically what happens is, like, whenever we are using a MongoDB into our service, and since this ID will be a unique identifier, so whenever we are creating a unique identifier and we want to create an auto-generated number for that unique identifier, MongoDB only supports three data types. Number one is the string, number two is the big integer, and number three is the object type. So here I will be giving the data type as big integer. So let's make it as ID, as a unique identifier, and the next thing what we will be defining is generated value, which means that whenever we will be creating a product, this ID will get automatically generated by the application. So this will be our primary key for our table. Now the next thing that we have to define is the product ID, which is more or less similar to the ID, but we want to define a specific product ID for an individual product. So we will be defining a product ID for a particular product, and each will be of type UID. Now the next attribute that we have to define for our product service are the name, rating, price, and the image URL. So let's define all this attribute into our entity class. So here on the product category, there can be plenty more attributes that you can involve into this list. For example, the description of the product, the date and time when it was registered, and plenty more. But right now, since I want to keep it simple and easy to understand, for that reason I will be only holding this much attributes for our class. Now let's define the getter, setter, and the constructor for this class. So here we are done with creating our entity class. Now the next thing what you have to define is, since we are creating this entity class for our MongoDB, so here in the MongoDB we do not provide the entity as our annotation. Rather what we define is called as document, because MongoDB stored the value in the form of the documents. So this is the only difference that you have to keep in mind when you are defining an entity class for the MongoDB application. Now let's create the next thing, and that is the controller class for our product application. So what we will be doing, we will be creating a class called as the product controller. And since this is a controller class, first thing what we will be doing, we will be annotating it with an annotation called as REST controller. And the URL pattern that it will be following will be /amazon/products. So this will be our base URL. Now within this controller class, let's now define the other URLs pattern that will serve the different purpose within this controller class. So the first thing we have to define is the post mapping, which means that with the help of this post mapping, we will be saving our data into our database. And you know that whenever we want to save our data into our database, we use the post mapping for our REST API. And the URL pattern that I will be following /save. So whenever we will be trying to hit this URL and we will be sending the data into our request parameter, the data will get persisted within our MongoDB. So let's define a function over here. And since here we will be sending the data in the form of the payload, so here we will be passing the data in the form of the request body. So I hope this is clear to you. And the data type which we will be sending over here is also of type product. So this is what we have for saving the data. Now let's create two more API endpoints for getting all the products from the database, and number two, getting the product details based on the product ID. So what I will be doing, I will be just copy pasting these two over here, and then I will be changing the request parameter over here. And after that, I will be changing the method type over here. So these two will be of type get mapping. And here the URL parameter that we will be following, get all products. So basically what this function will do is, like, whenever we will try to hit this URL /get all products, here it will list down all the list of products that are available into our Mongo database. So you can see that since it will return all the products in our front end in the form of the REST API, so here obviously cannot print out only one product, rather it will be printing out a list of products, and that is why our return type will be in the type of an array list. So hopefully this is clear to you. Now the next get URL that we want to create is search by ID, which means that, for example, if I want to search a particular product based on the ID, I have to follow this URL pattern for our service. So let's also change the name of this function. And here for this endpoint, the request parameter that we will be sending is in the form of the path variable, which means that here we will be sending the product ID as one of the URL pattern. So if you are confused with what I am doing over here, hold for a minute. Once I will be done with the entire flow, it will be very easy for you to understand. But as of now, let's proceed with further development, and after that I will be explaining each and every bit over here so that it will be very easy for you to get the complete flow of our application. So let's now save this thing and move to the next part of our application, and that is creating the service class and the repo class. So let's first create the repo class over here. And for creating a repo class, we will be first creating an interface, and let's call this as product repo. So the way we will be implementing this microservice is more or less similar the way we have created the application for the MySQL service. The only difference between these two is the way we handle the data and the syntax over here. So here what we will be doing, when we are creating an interface for our repository, we have to first annotate it with the annotation called as repository. And then what we will be doing, we will be extending a MongoDB repository over here. So if you have remembered that when we were creating our application using the MySQL database, at that time we were using the CRUD repository. But right now we won't be using a CRUD repository, rather we will be using a Mongo repository because we are connecting a MongoDB over here. Now let's define this T and ID, which will be same as what we do for the MySQL database. So what we have to do, we have to define the object over here, that is the product object, and the ID is the unique identifier for a particular product, which is nothing but a big integer. So that's it. Now let's define the three services that we need to define within this product repo. Number one is saving the data into our database. Number two is getting all the product details from the database. And the number three is getting a particular product details based on the ID. So let's define the three queries over here. So we are done with the repo class for our services. Now let's define the service class, which will actually hold the business logic for our API. So what we'll do, we'll create another class called the service class, and I will name it as product service. And let's first annotate it as service class. And as usual, let's first define three functions over here that will help us in handling the three functionality for our microservice application. So here I have defined three functionality which will handle the business logic for the product service. Now let's connect all these three together and let's complete the entire flow. So what I will be doing, from this service class, I have to call our repo class to perform the following activities. So what I will be doing, I will be creating an object of the product repo class. And first I will be auto-varying this service over here. So we are done with creating a reference of the product repo service. Let's now save the data into the database. So what we'll do, we'll first call this as product repo.save, and here we will be passing the data, that is the product data that we are getting from our controller class. And here if you remember that this product repo class will actually return the product that is getting saved into our database, which means that we need to capture this data over here as product, and we will be returning this prod from our service class. And that's it. This is quite simple. So just to simplify it even further, you can just simply remove this extra variable over here and pass the return type directly from here. And that's it. So here we are saving the data into our database. Similarly, we have to implement the find all service. We are done with the second service also. Let's now define the third service, and that is find product by product ID. And great, we are done with our service. So here I am getting a small error because of the fact I forgot to mention the parameter over here. And let's save it. And to make this much more easy to understand, let's not give find all. Let's define it as find by product ID. So let's copy this name from here and also replace it over here. So I hope this makes sense to you. So right now we are completed with the enter service package and also with the repo class over here. Now let's define the last and the final class, and that is the controller class, which will be actually responsible for calling the service class from this method. And to do so, what we have to do, similarly over here also, we have to create an object of the service class over here. So now since we are done with creating the reference of this product service, what we have to do, we have to just simply call this service class from this controller class. And that's it, we are done with end-to-end flow of creating the microservice using the MongoDB application. Now you must be thinking that where we have defined the MongoDB database over here. So we have not defined it till yet, let's now define it into our application. And the way we initialize a MongoDB application within our microservice application is quite simple and easy to do. So for that, what we do, we'll go to the resource and we'll go to the application property. And here what we have to do, we have to simply define the connection string for our MongoDB application. So let me paste the string over here. So here you can see the connection string is quite simple. So what we are doing here, we are first defining a URI for the MongoDB, and here we are defining a database within the MongoDB, and that is a product database. So this is simply only the thing that we have to define for creating an application using the MongoDB database. So let's now first open the MongoDB database and let's see how it actually looks. And for that, what we will do, we will open the MongoDB Compass. And if you are new to this MongoDB Compass, what you have to do, you have to simply click on fill in connection field individually, and here you have to run it locally. So here let's click on connect. Since here one of the instances of MongoDB is running into a local, it simply got the connection from there. So here we are done with creating the connection string with the MongoDB. Let's now run the application and let's see whether everything is working or not. And if not, then we will modify our code. So let's click on run. And here you can see our application is running at 8080 port. Now let's test this application using the Postman service to check our API endpoint. So what we will be doing, we will be opening our Postman application, and here we will be trying to invoke the services that we have created right now. So let's first see the controller class. So here you can see the URL pattern is Amazon/products. So what we'll do, we'll start with localhost. And right now the first URL that we want to test it out is the save URL. Means we want to save the data into our database. So we will be defining the save as our URL. So this is actually the URL pattern which will trigger this endpoint for saving our data into the database. Now we have to define the body of this service. So here we will select the body, and here we will be selecting as JSON. So hopefully right now this is clear to you, since this is a simple process of how to test an application using the Postman service. Now the payload that we have to define is the product ID, name, price, rating and the image URL. But if you look carefully, you can understand that this product ID should not be passed as a request parameter. Rather, it should get calculated automatically by the application, and it should be a unique identifier for each and every product. So let's first create the payload for our application. So if you have remembered right now, just I have told you that the product ID should be a auto-generated ID and it should not be defined within the payload. So to make it an auto-generated ID, what we will be doing within our service class, which consists of the actual business logic, here we will be writing a logic to define the product ID programmatically. So what we will be doing, we will be calling the set product ID, and here we will be writing a logic like UID dot random UID, which means that here this service will automatically define a random UID or a unique identifier for each and every product. So we do not need to implicitly pass the UID for each and every product. So I hope this is clear to you. So let's save it. Let's now send this payload and let's see what is happening in the background. So let's click on send, and if everything is working fine, we should get this reply in our response. So let's click on send, and great, you can see we are getting a particular response for saving the data into our database. So let's now analyze the response what we are getting into our database. So here you can see this is our unique identifier, which is a big integer for each and every item, followed by a product ID, which is a UID which we have defined within this service class right now, followed by the name, price and the rating that we are passing in the parameter. So this is actually working great. Now let's see how it is actually saving into our database. So here you can see if I open the Mongo Compass and just click on refresh, here you can see the new database got created over here, which is called as the product DB. And the entity class or the collection that got created within this Mongo database, and within this document we got the definition of a particular product, that is this one. And this is how the data gets saved into a MongoDB database. So pretty simple, right? Let's now save one more data, and after that we will be testing the other endpoint that we have created. So what I will be doing, I will be saving one more data over here. So for that, let's create it as iPhone 12. Let's increase the price to 75,000. Let's give it rating as 4.8, and also let's also change the image pattern for this image, and let's click on save. So here you can also see the data got saved successfully. Let's also verify it in our MongoDB database. So here you can see two instances of the iPhone got created into our database, which means that the data is getting saved into the database successfully. Let's now check the second endpoint that we have created right now, which is nothing but the get all product. So let's test it out over here. And this time we do not need a payload over here. So let's get rid of this payload and let's click on send. And if everything works fine, the output will be both the products displayed in the response. So let's see it whether it's working or not. So let's click on send and great, you can see both the products are getting displayed in our response, which means that our API is working fine. Let's now also test the last service, and that is getting the product by ID. So here you can understand that this API can be further modified into getting the product by the product name. So for example, if you want to enhance our application, you can easily create the search bar what we have defined in our Amazon frontend. So with the help of this integration, you can easily implement the search bar that we have implemented in our frontend. So let's now test this application for finding a detail of the product by the product ID. So let's consider that this is the ID for which I want to get the detail of the product. So here you can see the URL pattern defines that you have to give /search followed by the unique identifier, that is the product ID. And in this way we have also defined the URL pattern over here. So let's click on enter, and if everything is working fine, then we should only get this into our response. So let's click on send and great, you can see this is actually matching with the ID that we have defined over here. So here you can see with the help of simple modification of our code, we have implemented our next microservice, and that is the product details service, which is actually using a NoSQL database into background. So here right now we are done with two of the services, that is the user metadata service and number two is the product details service. So both of the microservices are working independently brilliantly, and right now it's time for us to join these two services together, and we have to see how actually the inter microservice application communicate between each other, and to establish the fact that how inter microservice communication happens into a microservice application. What we will be defining, we will be creating another microservice over here that will be our last microservice, and that will be adding product into cart, which means that from the UI, whenever a particular user is trying to add a product into the cart, we will be communicating between these two services, and we will trying to create a logic by which we can communicate between these two microservices that we have created right now. So let's define the third microservice within our application, and that is the add to cart service, which will be also a same replica of the user metadata service, because over there also, to make it simple, I will be using a MySQL database. So let's start with creating this application using the Spring Initializer tool. So let me close the entire project and let's create the third application over here. Now since we are done with creating our two APIs, one is the user metadata and another is the product detail service, right now we will be creating another API service, and that is add to cart service. So right now the add to cart service will be somewhat different from these two, because over here in this API we will see how we should do the intercommunication between the APIs. So without wasting much time, let's start with creating our add to cart API. And to make this add to cart API simple, here also I will be using the MySQL database. So let's start with creating the API service. So the first thing first, we will be creating our project from the Spring Initializer. And let's name this project as add to cart. Let's first add the dependencies. And let's click on generate. So we have downloaded the project. Let's import it into our Eclipse. So here you can see we have imported the project successfully. Let's now start with the implementation. So here also similarly, just like the normal microservices, we will be creating the four packages. One is the repo service for storing the information that a user is adding to the cart. Number two is a service class which will hold the business logic, and the controller for controlling the flow of execution. And there will be one more thing, and that is the entity class, where we will see how we can manage the different entity for this microservice. So let's start with creating the packages over here. Right now, since you already know how to create all these classes like service class, controller class and everything, so I will be first forwarding this part of the video. But if you are not comfortable with that, you can pause it anytime or refer to the code base that I will be uploading into the Git. So let's start with the implementation. And whenever I will be implementing the intercommunication and other things specific to this microservice, there I will be again start explaining what the things I will be doing. So let's start with implementing the basic structure over here. So here for this add to cart service, here we will be storing two things. One is the user ID and the product ID, which means that for example, you as a user want to add an iPhone into your cart. So obviously there will be a unique identifier or the product ID for iPhone, and that we will be storing it with your ID. So there will be a mapping between you and your ID. So for example, my unique ID as a user is 001 and I want to add to a cart an iPhone, and the unique identifier for an iPhone is 999. So let's take this as an example. Similarly, let's take an example that I want to add a charger for my phone. So over there also for that charger, the product ID will be different. So what we will be storing is for my ID, I will be storing the charger which might have a product ID as 555. So in this way, based on my ID, we will be storing all the product IDs which I am trying to add into the cart. Similarly, when I want to remove a particular item from the cart, we will be invoking the service that will delete the product ID from the database. So there will be primarily two endpoints, one for adding the item into the cart and number two deleting the item from the cart. So hopefully that makes sense that how we are planning to develop this API service. So let's start with creating the getter and setter for this entity class. So here you can see within our controller class, we have created two endpoints, one for adding the item into the cart and another for removing the same item from the cart. So let's now create the service class for that. So we have created the two methods for our service class. Let's now connect the controller with the service class. So we are done with connecting the two classes. Now let's first create the repo class and let's establish the connection with the MySQL database, and after that we will be implementing the logic for the service class. Because within this service class we will implement the actual logic of communicating between multiple APIs, and we will see how intercommunication between the API actually happens. So we will keep this service class implementation on hold and let's start with implementing the repo class and configuring the MySQL database into our application. So here you can see we have created a database into our MySQL application, and here into our application we have created a connection for our repo class. So we are done with creating everything. Let's now start with implementing the business logic where we will be communicating between the service. But one more thing I want to create is I want to add one more endpoint for our service, and that is listing down all the products that are available into my cart. So for that, what I will be doing, I will be adding a get mapping and I will be configuring an endpoint called as show. It will show all the items that are added into my cart. But as of now, I will be keeping the return type as void just to make things a bit simple. But after that, we have to change this void with an array of some objects that we want to display to the user as our items present in the cart. So let's start with the implementation over here. And here we will be passing the user ID of a particular user for which we want to display the card. So that's it. Let's also add this service into our service class. And let's also add this into our repo class. And let's save it. So I hope right now the service that we have created is easy to understand. So here we have created 3 endpoints, one for adding the item to the cart, one for removing the item from the cart, and one endpoint for showing all the items that are already present in the cart for a particular user. Let's now start with implementing the service class. But before that, let me call the service class from here. So yes, let's now start with the service class. So within the service class, the two endpoint that we have created, that is adding item to the cart and deleting item from the cart, will be a straightforward, because here we do not have to write too much logic to implement that thing, because here it is a straightforward implementation of adding an item to the cart and deleting an item from the cart. But the main logic of intercommunication will come when we will be implementing the display all product into our cart. And why I am telling that, I will be explaining it very shortly. So let's start with implementing the simple one, and that is adding item and removing item for the cart. And that's it. We are done with creating the business logic for adding an item to the cart and deleting an item from the cart. So let's now first test this application, that whether this thing whatever we have implemented until now is working or not, and after that we will be implementing the display all functionality. So let's now run our application and test it using the Postman client. And great, you can see our application is running successfully at 8080 port. Now let's first test this two endpoint that we have created right now. So what we will be doing, we will be sending a payload to save it into our add to cart database, and then we will be removing from the database. So let's first try it out. And in the body we need to pass a JSON object which looks something like the entity class, which is a cart object, which will have a user ID and the product ID. So let's give a user ID over here followed by a product ID. And let's click on send, but before that we have to make it as a post call. So if everything works fine, this data should get saved in our database. So let's click on send. So here you can see that status is okay because we have given an empty void response in our service. So that is expected that we will not get a response from here, but let's check it in our database. And great, you can see here we have saved some data. So since we have given an arbitrary value, that's why it's coming like this. So not an issue, but there is some data into our database. Similarly, you can test the delete or the remove functionality over here. So as of now, I'm skipping this functionality for you guys. So let's implement the main thing, and that is show items, where we will implement the intercommunication between the two or multiple APIs. So let's see how we will implement this display all property over here. So there are many ways in microservice architecture by which you can communicate between two or more microservices. For example, you can use a REST template, or you can use an Eureka service to do the communication. But over here, we will do something very easy. That is, we will be using a Feign client. So let's see how we will do the implementation. So before we do the implementation, that is the intercommunication between the two microservices, let's first do some prerequisite of setting up the two microservices. So over here, if you know, all the three microservices are right now running on the same default port, and that is 8080. But logically, if you think this is not possible or our ideal scenario when we are dealing with multiple microservices in our application, because all the three microservices cannot run on the same port. So we have to first configure the port for each and every microservice, so that each and every microservice runs on a different port, so that we can run all the microservices concurrently and we can do a intercommunication between each other. Otherwise, if one of the microservice is running on 8080 port, if I want to start another microservice on the same port, you will encounter a port problem, that is 8080 port is already in use. So to avoid that problem, what we will be doing, we will be setting the port ID for each and every services that we are defining over here. So defining a port for a microservice is quite easy. What we have to do, we have to go to the application.property, and here we have to define the port ID for this application. So for example, let me first change the server port of this one to port 8081. So this will be the first server that will be running on the port 8081, and let's also change the name of the application. And to change the name of the application, we will be using spring.application.name. And let's name this service as add to cart. Let's save it, and similarly for the other two microservices we will do the same thing. So let's open up the project, and here also we will change the port ID and the name of the project. And let's make this on port 8082. And for the third one, that is the user metadata, we will open that microservice and we will make it for port 8083. So we are done with the initial setup. Let's now do the intercommunication between the two microservices. So first you have to understand that what we actually want to achieve over here. So if you just first right now see over here, you will get to know that in our add to cart service, here we are actually saving two entries, that is the user ID and the product ID, which means that our data within the cart will be saved in this way, in the form of this. But what we actually want over here is like whenever we want to retrieve the card detail for a particular person, we actually want to get the product details of the product, not the unique ID of a product. So for example, as a user, you have 3 items in the cart. So your cart will actually look something like this. So let's assume you have 3 products in the cart. So for your user ID, you will be having 3 products. Maybe this one is one product, this is again second product, and this is the third product. But based on this product ID, we cannot tell that what is the exact product. So what we need the product details. And to get the product details, what we have to do with this product ID key, we have to get the details from the product details service, which is our second microservice. So actually what we are doing over here, we are getting the product ID from the cart service, and with that corresponding product ID, we are trying to invoke the product details service, and we are trying to invoke this method, and that is find detail by product ID. So if I can invoke this method, and that is find product by ID, and here in the parameter if I can give this product ID, obviously we can get the entire details of the product, which will look something like this, means the name, detail, rating and image URL. So we'll get the complete configuration of the product. So I hope that is clear to you that what is the problem statement that we want to solve over here. So let's start with the implementation and let's see how easily we can do it over here. So first of all, we have to see that from the add to cart service, we are trying to call the product details service. Means from here add to cart, we are calling this one. So what we will be doing over here in add to cart service, we will be creating a proxy server. So let's create a proxy server over here, which will be basically an interface. So let's name this proxy server as product detail proxy, since we are trying to call the product details using this proxy. So great, we have created a proxy server. Now let's add some of the dependency within our POM file for using the Fen client. So what we will be doing, we will be trying to get the Fen client dependency. Let's copy it from here and let's paste it within the POM file of add to cart service. So let's paste it somewhere over here. So let this get downloaded. Till then, what we will do the setup. So what we have to do within this add to cart function, here in the starting of the project where the main is defined, here we will define an annotation, and that is enable Fen client. So let's do the annotation. Now the next thing that you have to do is within the proxy class that you have created over here, we have to define this as our Fen client. So we have to give an annotation called as Fen client, which defines that this proxy will be actually a Fen client which will talk to another microservice. So obviously we have to define which microservice it want to communicate, and for that what we will do, we will put a configuration over here. So what we will do, we will first give the name of the microservice with which we want to communicate. So here we want to communicate with this product details service, which is having the name as product details. So let's copy it from here and let's paste it over here. And the next thing that we have to define is the URL path at which this service, that is the product detail service, is running. So here the URL at which this product service will run is actually the local host. So right now the product detail service is running on 8082 port. So that thing we have to define within this product proxy. And that's it, we are done with the configuration. Let's now build the actual logic of communicating between the two microservices. So here, if you know, we actually want to invoke the controller method, and that is this one, because with the help of this method we can get all the details of the product. So what we will do, we will simply copy this function from the product details and we will be pasting it within this proxy server. So what we actually want is we need to create right now a product object which will be actually the same replica of this product detail service. So what we'll do, we will simply copy this entire thing from here and we will create a similar object within this add to cart microservice. So here within this entity, here we will be creating another class called as product. And within this product class, we will be giving this entity object. Let's set the getter and setter for this method. But before setting the getter and setter for this method, let me show you some different way of creating this service. So what we will do, we will not be creating the normal getter and setter for this method. Rather, what we will be doing, we will be using a different service, and that is a Maven dependency called as Lombok, which will help us to create the getter and setter only by using the Spring annotation. Let me show you how. So let me first get the dependency of the Lombok one and let's paste it within the POM file of add to cart. So this is a new thing by which we are creating our entity object. So what we will be doing, we will be annotating this thing as getter, and here you can see our Lombok dependency is getting injected. Also we will be giving an annotation as setter. So we here with this simple annotation of getter and setter, what Lombok will actually do, it will by default create the getter and setter what we used to do by going to the source, creating getter and setter by this method. So actually here under the hood Lombok is doing the same thing for us. So simple, right? So let's save it. Now what we'll do, let's complete the proxy details service over here. So let's import the product details from our add to cart entity. And since this is an interface, let's get rid of this implementation. So here there will be no implementation, rather it will be a simple abstract function. Let's save it, and that's it. We are done with creating our proxy server. Let's now use this proxy server within this add to cart service. So what we'll do, we'll first create an auto varying of this dependency. And here we will now define the business logic of integrating the two. So I hope until this point this is simple and it was easy for you to understand. If you have not understand, just rewind the video for a few minutes and you will get to know what I am doing over here. Let's now implement the actual business logic of integrating these two services together. So what we actually need is like within this display all product in cart, we first have to call the function, and that is find all the product in the cart based on the ID. So what we will be doing within this add to cart service, we will be first calling the method that is add to cart dot find by user ID. So basically this will return an array list of the entire cart of a particular user. So here we will get an array list of all the items in the cart, which will be of this pattern. Now what we have to do, we have to iterate over this array list and we have to get the detail of all the product details from the cart. So what we'll do, we'll write a simple logic of doing so. So here we will write a simple for loop, and here for each and every item in the cart we have to invoke the method, and that is get product by ID. And what we will be passing over here, we will be passing product ID of each and every item of the cart. So hopefully this is clear to you. So what we are doing here, we are trying to iterate over each and every object, and from this object we are trying to get the ID, product ID of this object, which is nothing but this one, and we are passing this product ID into the proxy server by which we will be invoking the product detail service. So basically this product detail service will actually return us a product object. So hopefully this makes sense to you. Now what we have to do, we have to show this entire thing in a structured way, which means that it should be in this format. Which means that here you can see at the top level we have the user ID of the user, and after that it has listed down all the product description that are in his cart. So let's do that implementation, and that is quite a simple way of doing that. So what we'll do, we will be creating another Pojo object called as cart details. And here we will be storing two things, and that is the UID of the user and the list of objects in the cart. Here also we will use the Lombok getter and setter. So if you want, you can enhance this problem a bit more. What you can do here, instead of sending the user ID, here also you can return the entire data type of a user. Which means that based on this user ID, you have to get the user ID details from the next service that we have created, and that is the user metadata service. So there will be another intercommunication between the two microservices. So for that also you have to create one more proxy server, and the same way you have to perform that operation too. But as of now, to make it simple, I will keep it till this point. So what we will be doing within this add to cart service, here I will be creating an object of cart details. And within this cart details, the first thing that I will be adding is I will be adding the user ID of the user. So here you can see with the help of the Lombok, we are getting the set user ID function, though I have not declared the set user ID functionality within this cart details service. So this is the specialty of using a Lombok. So let's go back over here, and here what I will be doing, once we are getting the product into this object, we will be pushing it into an array list, and after that we will be pushing it into this cart detail. So let me first do it. After that it will be easy for you to understand what I mean to say. So let's first create an array list over here of product. So here what I will be doing, within this product list, I will be adding all the details of the product together over here. So here you can see for each and every iteration, all the product details will get inserted within this product list. So in this way, at the end of this iteration, this product list will have the complete description of all the products in the cart. And at the end, what I will be doing, here I will be setting it within this cart details. So that will be dot set list, and here I will be passing this product list. So hopefully this is clear to you. Now what we will do, we will be simply returning this cart list from here. So let's return this over here, and let's change the return type from void to cart details. Let's save it. Let's also change the same thing in our controller service, because over there in the controller also I have given it as void. So here also I will be giving it as the cart details, and let's return it from here. So I hope right now everything will be working fine, and if everything works fine, our output should look the way we have expected. So let's now run this application. So what we have to do, first we have to run our product details service over here. So here you can see right now the product details service is working on port 8082. So let's first insert a meaningful data over here so that we can map the product details with the add to cart service. So what I will be doing, I will be creating a meaningful entry over here. So right now it will be port 8083, a post mapping, and the URL by which we will be saving the data is /Amazon product /save. So let's first create a payload based on that. So let's save it. So here you can see this product got saved into our database, and this is the product ID for this product. Let's save it somewhere. Let's add one more product into our service, and that is a MacBook. Let's send it over here. So this is the product ID of the MacBook. Great. And this is the product ID of this MacBook. So this is the Apple Watch, and this is the MacBook. So here you can see both my server are up and running. So here you can see this is the first server, that is add to cart, and here is the second server, that is product detail service. So both the server are up and running and they are working on the different port. Now let's do a intercommunication between two and let's try out the functionality. So what I will be doing as a user, I want to add both this item into my cart. And to add this item into the cart, what I will be doing, I will be hitting this URL, that is this one. And here we have to send the payload of the cart, which is the product ID and the user ID. So let's do it. So let's take example. This is my user ID. And for this user ID, first what I will be doing, I will be adding the Apple Watch into my cart. Okay, so I got a 200 response, that's fine. The next product, and that is this one. So here also I got the 200 response. So for this user ID, that is this one, both the item got added into the cart. Now let me see that whether I can retrieve both the data simultaneously with the total metadata of the product or not. So to invoke that functionality, what I have to do, on the add to cart service, I have to invoke this method, that is display product in cart, where I have to pass the user ID of the user for which I want to retrieve the data. So let's do it. And the URL will be show followed by the unique identifier of the user, which will be nothing but this user ID. So if everything works fine, which means both the intercommunication and the functionality, you should get the relevant information into your response. And let's get rid of this payload. So let's click on send. So oops, here you can see I'm getting some error. So let me check the console. So here you can see I'm getting some error from the Feng client, means it is not able to hit the second API for communication. Okay, so I've done a small mistake, and that is, so here if you see the log, you can see how it is trying to communicate. So here you can see from the postman, I'm trying to search localhost 8081 slash this URL. Okay, and internally is trying to make the call to this server, that is 8082 search this thing. But if you have remembered in the controller where I have defined the product details, here you can see it is not only searched product ID. Along with that, we have something else, and that is product slash Amazon, which I forgot to give in the proxy server. So let's change the proxy server over here. So here what we will be doing, the get mapping will be this one. So let's restart that to get server. So the server is up and running. Let's try it again. So let's click on send. And great, you can see we got the exact output what we are looking for. So here you can see for this user ID, we are getting the list of the product that are in the cart. And here this is the product 1 and this is the product 2. So normally what we have implemented, we have just stored the product ID in the database. But while getting the value, we are communicating with other microservices, and here you can see we are getting the details of the product. And this is how we should do the intercommunication between the two microservices. So hopefully now it is clear to you that how we should do a intercommunication between the two or multiple microservices. So in this way, you can also enhance the problem by getting the user ID details from another microservices, and that is the user metadata services. So hopefully you guys have thoroughly liked the way we have implemented the microservices architecture for our Amazon cloning app. So if you have liked this video, do not forget to subscribe to my channel and hit the bell icon, because in this way I will be keep uploading different services like Amazon, YouTube and many more in the recent future. So if you have liked this video, please do give a thumbs up and share this video. And if you are new to my channel, do not forget to subscribe to my channel and hit the bell icon so that you never miss an update from my side and you are always ready for your next interview. Thank you.